So Bob and Bill are playing the following game, and Bill is pulling balls from a bucket, and Bob is promising to pay him the following amounts based on the color of the ball that he pulls out. Okay? So what we want to know is, what should Bill expect to win while playing this game? What should he expect his payoff to be? So what we're finding here is called the expected value. Now, all we need to do is find the expected value of a probability distribution, which is essentially just the mean of a probability distribution. So what we're going to do is we're going to list each of these payoffs here as our x values. These are our separate data values, and then we want to list the probability for each of these payoffs. Okay? So we've already started a chart here. I just want to list each one of these payoff amounts here. So we have $0, 25 cents, 50 cents, 75 cents, and $1. Okay. Now what we need to do is determine the probability for each of these payoffs. Well, you're going to get $0 whenever you select a yellow ball. Okay, so we need to find the probability of getting a yellow ball. Well, there are 15 yellow balls out of 25, so the probability is just going to be 15 out of 25, which is a simplified fraction of 3 out of 5. Okay. There are 5 red balls, so the probability of getting 25 cents is going to be the probability of getting a red ball, which is 5 out of 25, or 1 out of 5. Okay. There are 2 out of 25 pink balls, and that doesn't simplify any further, and 2 out of 25 green balls, and 1 out of 25. Okay. So what I want to do now to determine the expected value is find the mean of this probability distribution. Okay. So all I'm going to do is put this probability distribution into my calculator. So I'm going to put each of these gains in my first column. Okay. Then I'm going to put each of these probabilities in my second column. Now, if you feel that maybe you didn't simplify your fraction correctly, just put the original unsimplified fraction in it, because it doesn't really matter, because this is just going to convert it to a decimal anyways. So you just do 15 divided by 25, and notice it simplifies it for you, or I'm sorry, it converts it for you. Okay. Now, one thing you want to do before you proceed is to make sure that all of these probabilities add to 1. Okay. And they in fact do. You can easily check by just noticing all of the numerators add up to 25. So 25 divided by 25 is in fact 1. Okay. Also, you can check over here in the decimal representation. These all add up to 1 as well. So after you do this, you want to find the mean of this probability distribution, also known as the expected value. So all you need to do is hit Stat, go over to Calc, one variable statistics. We put all of our information in L1 and L2, so we just call list 1 and list 2 to calculate it. Press Enter. Now here we have the mean is equal to 1.9. Now generally you're going to list the expected value as an E instead of writing it as a mean. So we're going to say E is equal to 0.19. So what that means is that he should expect to win 19 cents every time he plays the game. Now obviously 19 cents is not an option. He can't win 19 cents by playing once, but if you were to take the average of all the times that he plays, he should expect to win 19 cents. So this is a pretty good game. He's going to expect to win something every time. Now Bob made some silly rules. Usually the house will make the rules so that this expected value will be negative, but it's just an example.